Well, good morning. After this inspiring kickoff, I think it's my turn to get down to earth a little bit by asking, are we ready for the software factory? Not technically, but from the management perspective. Yeah, you said it today in your talk more than 10 years ago. Mark Andreessen said software is eating the world. What did he mean? Well, this is my statement. There are many success factors for large companies. But in my opinion, there are only two existence factors. That is equity and software. For example, a bank, if one of these existence factors is missing, you can't have a bank. With those two existence factors, you can have a bank. Then additional success factors come into existence. So software and software engineering is 100% business critical. Not everybody in management likes this statement, but it's a fact, and we have to talk about facts. First of all, what do we mean by factory? What's a factory? We have so many different terms: handicraft, manufacturing, factory, factory of the future, which was talked about in the late 1980s. And my term is the self-organizing factory. What do we have to do that software engineering is done almost by itself? That should be our goal. That should be our goal. What's a handicraft enterprise? I personally like handicraft enterprises. I couldn't work there because I have two left hands. So thank God there is software. A good handicraft enterprise, we have a personal involvement and cooperation of the owners, we have sales order production instead of market production, and we have a manageable business volume, orders, employees and stuff. What was the historical way to the factory? Where did we start? Where are we now? Where will we be headed? First of all, handicraft business is a tool-assisted craft. The manufacturing, it's more factory than craft features. We have, for the first time, we had specialization. We have division of labor, very important. We have serious production. We have a manageable use of machinery. Today, an industrial plant, a factory, has to be a real factory. What do I mean by real factory? High machine use and no handicraft. I don't want to see handicraft in a real factory. I like handicraft, but that's not a real factory. We have scalability, we have machine-based serious production, we have, of course, automation, and we have planning and control. And this is essential. Without planning and control, there will be no future of a factory. We have some maturity topics, fitness topics for it's kind of the degree of machine use. It's a high capital investment. Classical factories have a high capital investment and a great need for know-how. We always think about know-how is there. No, it isn't. It is not, especially today. Of course, handicraft enterprises are up to date till now. Good carpentry, to find a good carpentry today is an art in itself. What's the features of the historical factory? And I looked at my last Brockhaus in 1988. What did we have there? It was, it said it's production of semi-finished and finished products in large quantities, use of specialized machinery, high capital investment, operating resources, and so on. More interesting, what did Brockhaus say in 1988 to the factory of the future? First and the second one is Oh, the first one was the same. The second one, highest possible degree of automation. Back then, highest possible degree of automation, few control persons, and no physically working people. And process control systems and robots, not only for production, but also for material transport, supply and removal of tools, and monitoring control of product quality, machines and equipment. So, and back then, even back then, it was stated fully computerized manufacturing, digitally controlled machine tools, and automation chain extends far beyond the actual production, all the pre and post phases from design till sales and service. So this is reality today. And from the late 1980s to date, it's not a very big period of time. It's reality today. A car maker could not survive without this. No chance. And I think this is a metaphor for what we are talking about later on. And I tried to see the path and what are the drivers. If we don't understand the drivers of change, we can't cope with the change. And what are the drivers? Well, we have the biggest driver, in my opinion, in the decade was alphabetization. It led from handicraft to manufacturing. You can't have a small manufacturer without being able to read and write. Next was industrialization. It led us to the factory. Automatization, to the factory of the future. And now we have digitalization and, of course, analytics and machine learning. And we will have the self-organizing factory. We have to have it. And I don't have a term for analytics and machine learning like digitalization. It's sation, maybe sensation. You know. So, state-of-the-art software engineering has always tried to create the conditions for the software factory, always. And when I made my PhD many years ago, I read a paper, an original paper from the end 1940s. And back then, there was this discussion. Back then. It's always the same. It's reuse of artifacts of any kind, code, modules, templates, you name it. It's, of course, the evolution and modernization of development processes. Think about the legendary chief programmer team. Very modern back then. Via waterfall, via prototyping, via to DevSecOps, Agility 2, I think we will see artificial intelligence ops. We have process automation, testing, building, releasing, rollout, and all the stuff. And we will have, of course, coding by generative artificial intelligence. We will have it, definitely. The question is, how do we cope with it? And, of course, analytics and metrics, static and dynamic. And you see the green signs, and you see the not so happy smiley. Because in my opinion, we are far from being at a best practice approach. And not every software producing company is a software factory. We should be very precise when using the term. You can be a successful software production company without being a software factory. But we'll see what happens if we're not. Well, of course, there are so many arguments why we don't need a factory approach. Very successful arguments. First of all, well, it's not invented here. The frequent mindset problem you can find everywhere. Well, code analytics is far too big for us. Of course, that can be true, especially for small and medium-sized enterprises. We have high specialist attitudes, the best software engineers. Well, sometimes they are justified. It's a lack of know-how on the developer level that can be remedied if you recognize it on the management level. It's an investment aversion. That's, in my opinion, the biggest single problem. I'm always hearing the the sentence, the statements, well, analytics doesn't write code. And we have a lack of know-how on the decision makers level, and that's always dangerous. Always. There is one big difference between industrial manufacturing and software development. You know it, of course, but I want to recap it. Manufacturing of material, industrial goods, has three main processes. Three. First of all, the design and development of the prototype. Second, the development of the industrial series production. And third, the production itself. And history showed us these three processes pushed itself. They were pushing. And improvement came for all three processes. In software development, thank God, or not thank God, we have only one iterative main process. Design, development, test, build, release, rollout, and monitoring in one big process, and we have no serious production. And which characteristics of a factory, of a real factory, should also be found in a software factory? Well, we need an engineering definition. If we don't have an engineering definition, it's not a factory. Of all processes and artifacts, and of the proper use of all tools. We need transparency, measurability, controllability. A modern manager is not afraid of transparency. If he's afraid, it's not a manager. We need availability of static and dynamic parameters for all our artifacts. We need assured repeatability and continuous improvement process. Another statement, software development has long since diversified from craft to industrial scale. We have programming in the small and in the large. But does this also mean that software development on an industrial scale today is actually factory industrial? Seamless engineering? Can we look into the mirror and say, yeah, of course we have seamless engineering? Development in the small is manageable scale, often scripting based on the low and less code platforms. Yeah, it's typically in small and medium-sized companies, and that's okay. That's okay. Development in the large is a little bit different. We have the full scope software development lifecycle. It's all in. Do we have the same opinion what all in means? I don't think so. Large companies in all industries that require in-house development as well as standard software do have to cope with it. And of course, the manufacturers of standard software of all types itself. The big global players, in my opinion, today are the massive drivers of the industrialization of software engineering. You name it, the big 5, the big 10, the big 20. Those are the big drivers. Those are the big drivers. Just a few things. What are the drivers of the ongoing topic? Of course, complexity of increasingly powerful technology stacks. It's incredible what you can do with today's technology stacks. It's incredible. We have communities and open source resources. You don't have the chance to go to a developer and say, well, you are not allowed to be in that community. They said, okay, then I'm gone. He or she says, live with it. I will do that. I will share my code. Do something against it. Good luck. Of course, the fear of no longer being able to adequately manage the overall complexity. Easy access to cloud services. It's incredible what you get in the cloud for your money. Scaling needs. Increasing amount of legacy software. I'm not very happy with the term technical debt, because when you have a discussion at the C-level with technical debt, what? What, do we have a debt? The advances in analytics tools, of course, artificial intelligence and security engineering. In my opinion, results-oriented management is not possible without transparency. It's pure actionism. So what is transparency in our present context? What is it? That's easy. Transparency, on the bottom, you need to establish measurability. Without transparency, you can't measure at all, of course. It's so simple, but it's, well, you have to say it. Measurement is quantification of transparency. Then you have control ability. Then you have the chance to have automation. And our goal has to be the self-controlling software factory. We have to have that. That is the engineering approach of the next decades. And the term software factory, you have two meanings in the market. First of all, it's a product suite of a manufacturer, like one of the big five, or the big 10 or whatever. But that's not the software factory I'm talking about. That's adapting, assembling, configuring based on a factory scheme. That's okay, typical for small and medium-sized enterprises. That's okay. We should talk about a factory when we are talking about the organizational form of a process defined in engineering terms. Development and maintenance of software, transparent, measurable, controllable, assured, repeatable, and so on. That's a software factory. Yeah, that's easy. A software factory in the meaning of a product suite of a manufacturer. It's typical frameworks, product templates, process templates, domain-specific languages, systems for code generation, various tools. It's very vendor-specific. It's usually domain-specific. It's optimized for certain classes of applications, and so on. And real software engineering, software development, you have only for when you need some missing components. Software factory in the meaning of engineering processes is something different. It's an organizational form, as I said before, of an engineering-defined process with everything what's stated here. Design, coding, testing, building, releasing, monitoring, knowledge, tools, templates, and so on. Cloud technologies for infrastructure abstraction, and so on. It has to be vendor neutral, it has to be domain neutral, and universally applicable. The target market is the big market of companies that develop business-critical software. Well, we started with software is eating the world. Some years later, Ed Pearson said, well, software has eaten the world. It has happened. What do we need? I was asking myself, why don't have all companies a mature software factory yet? Why is it? Well, a software factory is the Champions League of software engineering. It's complicated. It's not easy to have it. It requires high capital investment, it's a factory, and corresponding know-how. And it's tedious to establish, it's laborious. It doesn't come from scratch. We have a glaring shortage of very well-educated business computer scientists, and at all levels, from the coding level to the decision maker level. And there is no improvement inside, on the contrary. And in my opinion, the overriding importance of software engineering is not completely clear to all C-levels. The impact, what happens today with software engineering, with artificial intelligence, is not clear. We have relatively few technology people on boards in the digital age. What's the consequence? When we are honest, we see hardly any proactive management action pro-software engineering on decision maker level. I always say it is already seen as a progress when software engineering is no longer seen as a cost factor. It's a survival factor, and agile work is allowed. But abstract factory topics such as analytics and their benefits are enormously difficult to sell, I think. Analytics doesn't write code and is expensive. There is no budget for it, as I told before. Linus Torvalds, talk is cheap, show me the code. What do we do at Raiffeisen Software? First of all, I thought I will show you our dashboards, and I said, no, you're not interested in our dashboards. But what do we do on one slide? We have, of course, an agile development model. We have also an agile structural model, product-oriented or social structure, and we have transparency. We decided 10 years ago to give we are shared in-group software factory, hopefully. We are giving access for our customers to our systems with a drill down to the lowest level. It's our customer portal. It's mature and proven. It's up to date. It's a real-time. You can see real-time details on all phases and artifacts of all projects. And we have, of course, our own dashboards. It's our called iSpot, internal single point of truth. We have a basis. We have various KPIs as an input for management. The main target group is development management, and of course, we as channel management. And we have various reporting engines, release automation. What's next? By the way, this was an excellent cover story by Der Spiegel. The graphics was done by an artificial intelligence, not by a person. And you can read it how the prompt was given. What's next? AI now is eating software. Artificial intelligence and the software factory, in my opinion, analytical and generative AI will have a tremendous impact on software engineering in all domains. In my opinion, artificial intelligence will form the basis of all engines in the software factory. And when you look what's going on in the communities with Copilot and Tab 9, it's fascinating. And a new generation of software engineers is growing now, looking at us like, I don't know, like the first car manufacturers looked at the persons caring for horses, or I have no idea. This is very interesting. Conclusion. Yes, of course, we are able to implement a software factory. We are. Everything is there. Look at Serene. Everything is there you need, if we are allowed to want it. Software engineering always strives for factory approaches. If it doesn't drive, it's not engineering. But establishing it is enormously laborious and cost-intensive, but worthwhile undertaking. Software engineering has universal problem-solving competence, and that is the core problem. It will continue to diversify, also by means of factory approaches. In my opinion, every company, every large enterprise will have to choose its factory approach, or one day find itself in a pure consumer role. In a pure consumer role with corresponding dependencies. And that's the alternative to having a software factory. You are in a consumer role. And what I call the result-oriented controllability is the core benefit of a software factory. Complexity remains controllable. Quantifiable transparency is the management lever. Yeah. Thank you.